So let us start this new chapter, gravitation, or MCQ. First question, test number 27. Actually, gravitation topic we have seen in the last year, FIGC. Question number 1. If a planet of given density were made larger, keeping its density unchanged, its force of attraction for an object on its surface would increase because increased mass of the planet, but would decrease because of larger separation between the center of the planet and its surface. Which effect dominates? Increase in mass, increase in radius, both the effect of attraction equally, both affect the attraction equally and none of this. CND is wrong आहे. तर या ठिकाणी कोणाचा इफेक्ट जादा होईल, मास का रेडियस, ते आपल्याला द्यायचं आहे. सो द सिच्युएशन इज लाईक दिस. कन्सिडर ए प्लॅनेट of mass m. This is the center of the planet. This is a body of mass m kept on it. R is the radius of the planet. So F is equal to gravitational force of attraction on a body of mass m kept on the surface of a planet of mass capital M and radius equal to R. Therefore, F is equal to GMM upon R square. This is equation 1. Where mass of the planet m is equal to rho multiplied by 4/3 pi r cube. This is equation 2. Put 2 in 1. Therefore, F is equal to G rho 4/3 pi r cube m upon r square, and therefore F is equal to 4/3 pi G rho m r. This is equation 3. So since G rho and m are constant, and therefore F is directly proportional to R. This is equation 4. So the result is like this. Equation 4 shows that effect of radius R is more than effect of mass m. Therefore, as R increases and F is inversely proportional to R square, therefore the force F is affected more because because of increasing radius r. Increasing radius r. So r has a predominant effector. That r has a dominant effect on f, and therefore the correct choice is B. B is correct. अपन एरर एनालिसिस मेथड पण यूज करू शकतो. Next, second question. Two particles of equal mass, small m, go around a circle of radius r under the action of their mutual gravitational attraction. The speed of each particle with respect to their center of mass is. The दोघांचं center of mass centerला दिले. So the figure is like this. This is a circular path. This is the center. So one particle of mass m is here, other is at diametrically opposite point. So this radius is equal to r. This is also r, like this. So on each particle, the centripetal force is acting in this direction. Cpf is equal to mv square upon r, like this. So G is equal to gravitational force of attraction between m and m when they are at diametrically opposite ends as shown in figure. And therefore Fg is equal to G m upon 2 times r bracket square. So G m upon 4r square. This is equation 1. Now in this case, why we assume this position? Actually there is a force of attraction between them if the mass m is also here. So when this mass is considered here on the circumference, then the force of attraction between the two particles will exist, but it will not be directed toward the center. It will be directed along this line chord, and therefore we want the force which is acting this along the radius and toward the center. You can note this point. If two masses m and m are not at diametrically opposite ends, then FG is not directed toward the center, of circle, that is center of mass of the system. FG is not directed toward the center of the circle. Therefore, FG provides centripetal force necessary for circular motion of two masses on a circle of radius is equal to r. Therefore, centripetal force is equal to Fc is equal to m v square upon r. This is the equation second. Since Fc is equal to Fg, therefore, using 1 and 2, mv square upon r is equal to gmm upon 4r square. So 1 m will get cancelled, 1 r will get cancelled, therefore v square is equal to gm upon 4r, and therefore v is equal to under root gm upon 4 times r. Gm upon 4 times r. And therefore, the correct choice is B. Therefore, B is correct. This centripetal force is necessary for circular motion of the two particles, like this. Next, question number 3. If the density of a small planet is same as that of the Earth, while a radius of the planet is 0.2 times that of the Earth, the gravitational acceleration on the surface of the planet is so the given quantity is like this. Rho p for planet is equal to rho e for Earth. Radius of the planet rp is equal to 0.2 times the radius of the Earth. So gravitational acceleration on the planet gp is equal to question mark. Gravitational acceleration on the Earth is equal to g. Like this. So again you can consider like this. This is a planet of radius r, mass m. This is the body of mass m. So F is equal to gravitational force acting on mass m kept on the surface of a planet of mass capital M and a radius equal to capital R. Therefore, F is equal to gmm upon r square is equal to m into g, so m will get cancelled. Therefore, gravitational acceleration on the surface of planet is g is equal to gm upon r square. This is the question now. But mass of the planet capital M is equal to rho multiplied by 4/3 pi r cube. Therefore, equation 1 becomes G is equal to G into rho 4/3 pi r cube upon r square, and therefore G is equal to 4/3 pi G rho r. This is equation 2. Since G and rho are constant, therefore G is directly proportional to R. This is equation 3. This is equation 3. Therefore, Gp upon G is equal to radius of the planet Rp upon radius of the Earth. So this is equal to 0.2 Re upon radius of the Earth. Re cancel, and therefore gravitational acceleration on the planet is equal to 0.2 times G on Earth, so that is equal to 0.2 times G. So gravitational acceleration on the surface of planet is equal to this much. So the correct answer is A. Therefore, A is correct. Next, question number 4. Again, it is based on the same thing. So we have derived this equation, dm is equal to dr square. You can use this equation directly. Fourth, the ratio of radii of Earth to another planet is 2/3 and ratio of their mean density is 4/5. If an astronaut can jump to a maximum height of 1.5 meter on the Earth with the same effort, underline this, with the same effort, the maximum height he can jump on the planet is equal to. So with the same effort means what? So given quantity is like this. The ratio of the radii is 2/3. So Re upon Rp is equal to 2/3. Density of Earth to density of planet is equal to 4/5. Check the value. Then height on the Earth is 1.5 meters. Height on the planet HP is equal to question mark. So astronaut jumps with same effort. Since an astronaut jumps with same effort with same effort on planet and Earth. Therefore, work done is the same during jumping. Therefore, potential energy of astronaut is the same on Earth and planet. This point is important. Potential energy of the astronaut is the same and therefore P on planet is equal to P on Earth. So M into G E into HP is equal to M into G E H E. This is equation 1. Where this M will get cancelled. So GP, or you can write down HP is equal to G HE upon GP. This is equation 1. H is equal to height of the jump on planet. So now you can use this equation. But G is equal to 4/3 pi G rho R. Then G upon GP is equal to 4/3 pi G rho E R P upon 4/3 pi G R P rho P R P. So this is equal to density of Earth upon density of the planet multiplied by radius of the Earth upon radius of the planet, and therefore gravitational acceleration of Earth divided by gravitational acceleration of planet is equal to, now G upon Gp is equal to 4/5 and Ra upon Rp is equal to 2/3, so that is equal to 8/15. 8/15. This is equation 2. So put 2 in 1. Therefore, height of the jump on the planet is equal to G upon Gp is equal to 8.15 multiplied by height 1.5. So that is equal to 8/10. That is equal to 0.8 meter. 0.8 meter. So the correct answer is this. height of the jump on the planet is equal to 0.8 meter. So the correct choice is B. Therefore, B is correct. So the given condition is important. So the given condition is this: the astronaut jump with the same effort on the planet as well as Earth. So during the jumping, work done by the astronaut is same. Therefore, work done is always stored in the form of potential energy. So potential energy of the astronaut is same, and therefore potential energy on the planet is equal to potential energy on the Earth. This potential energy is given by mgh, where m is the mass of the astronaut, so it will get cancelled. So in this equation, why m get cancelled? Because the astronaut is same. M is equal to mass of an astronaut. So it will get cancelled like this, and therefore the height through which the astronaut will jump on the planet, hp, is equal to g upon gp. So the g upon gp is given by this equation. G is given by this 4/3 pi. We are using this equation from the last problem. So G is equal to 4/3 pi G rho R. So this G will get cancelled, 4/3 pi will get cancelled, and therefore density of the Earth upon density of the planet is equal to radius of the Earth upon radius of the Earth. These ratio are given like this. Therefore, the ratio of the gravitational acceleration is 8/15, and by using this, we get height on the planet of the height of jump on the planet is equal to 0.8 meter. So actually gravitational acceleration of the planet is more, and therefore height will be lesser. So actually this relation can be used as G1 G2 G1 H1 is equal to G2 H2. So if the gravitational acceleration increases, then definitely height will decrease like this. Next, question number 5. If the Earth stops rotating, the value of G at the equator, so what to find the value on the equator? So the effect of latitude, angle of latitude phi, and the angular speed omega is studied combinedly, and that equation is like this. So let g phi is equal to gravitational acceleration at latitude phi. Therefore, g phi is equal to G minus G is a acceleration, so it is given by R omega square cos square phi. So this is the equation capital A. Phi is equal to angle of latitude omega is equal to angular speed of Earth. R is equal to radius of the Earth. Now, our problem is at equator. So what will happen at equator? At equator, phi is equal to 0 degree. Therefore, cos of phi is equal to 1. Therefore, cos square phi is equal to 1. Therefore, equation A gives g phi is equal to g minus r omega square. This is equation 1. When Earth is rotating, then omega is not equal to 0, and then g phi is equal to g minus r omega square. When this is same equation. When Earth stops rotating, then omega is equal to 0. Therefore, the gravitational acceleration g dash phi is equal to g minus 0. This is equation B. Comparing B with A. So g dash phi is greater than g phi. This is equation B. And therefore, the value of gravitational acceleration increases. Value of gravitational acceleration, and hence weight of the body. Question असा पण भेटलेला होता. The value of gravitational acceleration and hence the weight of the body increases. So the correct answer is A. Okay. A is correct. Now you can add one more part. Now this is the problem at equator. Now if we consider the same problem at the pole, what will happen? At the pole of Earth, either north pole or south pole, phi is equal to 90 degree. Therefore, cos of phi is equal to 0, and therefore g phi is equal to g minus 0. Therefore, omega has no effect on g at pole of the Earth, and then in this case C will be correct. Then C will be correct. तर दोघे केसेस आपण कन्सिडर केल्या, पोल आणि इक्वेटर. ऍक्च्युली आपण अर्थच आहे तर कुठल्याही दोन अँगल ऑफ लॅटिट्यूडचे व्हॅल्यू यूज करू शकतो. So I will read question number 6. Question number 6 is actually this part. If the Earth were to spin faster, acceleration due to gravity at the poles, no effect means it will remain the same. So in this case, C case will be correct. G5 is equal to gravitational acceleration at latitude phi is equal to G minus R omega square cos square phi. This is equation capital A at poles of Earth. Angle of latitude phi is equal to 90 degree. Therefore, cos of phi is equal to cos of 90 is equal to 0 degree. Therefore, equation A gives G5 is equal to G minus 0 equation 1. So, at pole, the value of G5 is independent of angular speed, omega. So this is the important result. At the pole, G5 is independent of omega. Therefore, the increase in speed therefore, if the Earth spin faster with larger value of omega, G5 remains same, unchanged. G5 remains unchanged, and therefore gravitational acceleration remains same. Therefore, correct choice is C. Therefore, C is correct. C is the correct value. Next, question number 10. 7, 8, 9 we will consider next time. A body is at rest, underline this. A body is at rest on the surface of the earth. Which of the following statement is correct? A. No force is acting on the body, only weight of the body acts on it. Net downward force is equal to net upward force, and none of the above statement is correct. So, what is the correct statement? So, this is the planet of mass M. This is the radius R, and this is the body of mass M. So, the condition is given like this. When a body is on surface of earth, then weight of the body W is equal to M into G is equal to FG. FG is equal to gravitational force of Earth on body. Therefore, Fg is equal to weight is not equal to 0. Therefore, A is wrong. Weight act होता है when body M is in contact with earth, then earth exerts normal reaction on it. Therefore, on it, in addition to Fg, therefore B is wrong. इथे काय म्हटलं only weight is acting, not only weight but normal reaction is acting. Third point, since the body is at rest, since the body is at rest on earth surface, therefore normal reaction N, which is vertically upward, balances the weight W acting vertically downward. Therefore, N is equal to W. So N is acting vertically upward, W is acting vertically downward. They are equal in magnitude, opposite direction. Therefore, the body remains at rest, and therefore the correct place is C. Therefore, the C choice is correct. Okay, we will stop here. Question number 7, 8, 9 are remaining. They are again related with the basic property of gravitational field. So we will see them next time first.